With me here in the studio this morning from Roskill, I'm joined by both Charles Cooper and Oliver Heathman. Good to see you both. Good morning.
Good morning.
Hello, good morning.
Here discussing your Greenfield battery raw material projects report for the 2020s. Charles, if I can get a couple of words from you just to start us with, the first of its kind, this report. Just tell me a bit more about the overview, what the thinking was behind publishing this.
Well, that's right, yes. We've decided between Scarn Associates and Roskill to put together a substantive report looking at the raw material supply for the battery market. Certainly as the industry looks full steam ahead for the expansion within the electrification of vehicles and off-grid supply. And what we've found is that many investors, many industry participants are looking for substantive information on the new projects, the Greenfield projects that could be developed over the next decade. And these projects cover the metals, the primary metals that go into raw material battery supply, include lithium, graphite, manganese, nickel sulfates, and cobalt sulfates, and hydroxides, and manganese. And looking at them, they're quite a diverse and disparate bunch of projects. And we thought a study examining these projects that could come online would be essential reading for bankers, investment bankers, whether it's debt or equity, governments, any industry participant ranging from private investors all the way through to those people actually developing the projects themselves.
Well, Oliver, give us a bit more detail as to what's actually in the report.
Yeah, absolutely. So this is a sort of a 400 plus page report looking at those Greenfield projects. And I think the point to note is that, unlike, although this kind of study has been carried out extensively for sort of commodities such as the ferrous sector, base metals, precious metals, actually given that the battery sort of sector have generally been sort of a fairly sort of niche set of commodities, that actually this kind of study hasn't been done on projects like this. So we put this study together, which is totaled, as I mentioned, 400 pages, and it covers sort of 50 plus projects that could contribute to supply within the next decade. So the report really sort of includes a project by project assessment. So we're looking at sort of critical factors such as the resource quality, mining and processing methods used, and then sort of looking down further at the sort of the operating and capital costs behind these projects, and then really sort of analysing them on a like-for-like basis, which has been sort of the challenge of the report, given, as Charles mentioned, there's such a sort of desperate bunch of commodities.
Well, Charles, can you give us some examples, some of the more interesting findings that have come out of it?
Absolutely. Well, looking at these projects, because we talk about a bunch of commodities that are often the byproduct of primary metals like nickel or even copper. So, for example, in the DRC, we expect to sort of see most of the cobalt supply coming online from effectively what they are defined as is a copper mining operation that has byproduct cobalt. So the report tackles how we can bring these projects together and analyze them on a like-for-like basis. So we look at things like reserve resources, what's actually physically in the ground and how does they compare to other assets globally, how the mining method is going to influence the chance of success of getting that out of the ground. The processing and the extraction, the metallurgy is all basically dealt with in simple language within this report that allows investors and any other industry participant, whether they have an extremely wide and broad knowledge on this sector or just generalists as well. So it's a sort of it's basically caters for everybody. But these findings allow us to then compare these projects on a like-for-like basis, whether it's on costs, the operating costs that they produce, or all-in sustaining cash costs. And it allows us to then sort of say whether or not these operations look competitive versus the rest of this peer group, but also existing operations as well. So it basically allows us to assess the competitive risk, both on operating costs, on capital development costs, on the products that they produce as well. So when we look at these sort of assets, we can then start to assess them. And because we've normalized the data set, so we use commodity prices that are based on Roskill's long-term price, which are often different from what many industry participants and developers might be putting into their studies and presentations and the sort of the marketing of their own greenfield projects. So for example, in graphite, we have observed that many of the graphite producers put out sort of commodity price forecasts, which their projects are based upon, which could be almost 2 to 2.5 times the current graphite concentrate price. So what we've done is normalize that data set, put everything on a like-for-like basis, so you can now strip away, debunk some of the, let's say, over-optimistic assumptions being made. And we've done this all the way through all the other metals as well. And when we can then also do something quite clever by putting these projects together, so we can then assess how a lithium project might look versus a cobalt project.
Yes, as you can see by the chart, like here we've tried to, as Charles said, normalize the data set. So here we're showing the profitability on an operating cost basis of all the projects we analysed. So here we're using the all-in sustaining cost margin as an indicator of operational profitability over the life of the mine. And I think the key thing to take home that is that actually, you know, you have the most profitable projects on the left, and you're really seeing here is a clustering of these lithium projects, which is quite interesting in itself. It also kind of leads through to the fact that, you know, these projects look very attractive often on an operating and capital cost basis. But actually the thing to really understand with lithium is the technical risk associated with them. So, you know, just a few years ago, there were a handful of lithium or major lithium producers globally. And actually these were often focused on the best deposits. And generally, they didn't have a requirement to ramp up to the capacities that many of these projects are touting within their studies, simply because the market was relatively small. And actually, they just had to grow at a pace to meet a sort of a modest increase in lithium demand. And so when you sort of come back and look at the sort of the brine sector, for instance, many of the projects analysed are sort of talking about producing lithium through conventional solar evaporation. Which is interesting in itself. You have sort of one or a couple of operating examples, predominantly within Chile. And actually, you know, this processing method outside of this region or outside of the Atacama, where you have reasonably good grades and good climatic conditions, is relatively unproven. You've seen sort of one major project come online over the past sort of decade, and that's Orocobre's project in Argentina, which has really struggled to sort of ramp up to capacity, showing highlighting some of the issues with that. It's particularly sort of related to sort of the deposit quality, but also sort of, you know, the understanding of how you sort of model or how you sort of concentrate the brine within these solar evaporation ponds. So that's really kind of this technical risk that people don't understand. But you can also look at sort of the other sectors, so sort of the mineral sector, where the hard rock mines, predominantly in Australia, is considered a bit more sort of straightforward processing, but many of the producers there, as we're currently witnessing, are having problems ramping up their plants to capacity and getting the design recoveries. And much of this is down to just this lack of understanding. You know, you have a very small industry that's trying to grow rapidly, and the technical expertise and the sort of the base knowledge to do that is actually very limited, just because it was such a niche market. So you're really sort of faced with sort of many challenges, and I think that's the kind of take home as an investor in a lithium project, is you have to stomach quite a lot of technical risk when you're looking at these projects.
Well, that's right. I mean, you know, when you look at some of the other commodities also within this report, you know, from the cobalt and the nickel side, and as I mentioned earlier, that sort of much of the cobalt production in the future is going to come from either a copper mining operation or potentially from nickel laterite producers. So this presents a really interesting challenge, and there's a couple of things here which are worth highlighting, certainly within this sort of interview here, really just in terms of the overall scope of the report. So what we found is that many of these projects are often quite complex, technically challenging. That is certainly true of the Australian nickel laterite, cobalt producing projects. They're often using a technology that is similar to HPAL, nickel HPAL, which is high pressure acid leach, that has had significant cost overruns, capital cost overruns over the last few decades of the new projects that have been brought online. But we've also sort of seen significant cost overruns and ramp-up delays. So a project might say, look, we can get up to full capacity in 3 years, but this industry has been facing 5-6 years in terms of sort of delayed startups. And it's created significant working capital cost overruns that has meant that some of the producers, some of the majors, have just basically got it wrong. So we are attempting within this report to debunk a lot of what the junior and the mid-tier sector are sort of saying about their own projects. We look at it from a slightly jaded perspective, but effectively, we try to caveat all of our assumptions and make it very clear for the reader of this within this report. So not only do we have the challenges, the technical challenges of building these projects, but we also, and one of the things that is a key to this report, we look at the products being produced. Now, all of them are producing intermediate products at the mine gate. So rather than a mine producing LME grade copper cathode, for example, which is then taken off and turned into copper wiring and tubing, they're producing these intermediate products that should then go on to a smelter refiner or some form of conversion process to be turned into the exact raw materials that go into the back end of a battery manufacturer. Now, these battery manufacturers require a very high specification product. And it's very challenging for a mining company, let alone a very, let alone mining companies with a lot of money like a Rio Tinto or BHP, to deliver a consistent product. So we're advocating that this presents a significant risk to people developing these projects, to investors putting money, whether it's equity or debt, into this market, as well as, these are the challenges that are going to face this industry over the next decade. So this is going to be where the new supply is going to come from. So we hope that this report will give investors from a wide scope of understanding and disciplines within this industry, from non-technical people, but financially literate people in the investment banks, any of the sort of funding institutions, all the way through technical guys who want to benchmark their own assets against a big data set that we've put together for this. And this should be hopefully a warts and all critical risk assessment for the whole industry. So there we go.
Very interesting. Charles, Oliver, good to see you both. Thanks very much for coming in.
Thank you, Andrew.
Thank you.